Welcome students. In part 2 of non-ferrous metals and alloys, I will discuss about aluminium and its alloys and about the bearing materials. Aluminium and its alloys. The properties are: it is a light metal which has a density about 1/3 of steel or brass. Aluminium is a very good conductor of electricity. It has a higher resistance to corrosion than any other metals. Aluminium is a good conductor of heat. It is very ductile. It is non-magnetic. Melting point of pure aluminium is about 650 degrees centigrade, and the fusion range of most of the aluminium alloys varies between 520 degrees centigrade and 650 degrees centigrade. Although pure aluminium is not particularly strong, it forms high-strength alloys in conjunction with other metals such as copper, chromium, nickel, iron, zinc, molybdenum, silicon, and magnesium. Some of the aluminium alloys are more than 4 times as strong as the same weight of mild steel. They are malleable and ductile. They exhibit toughness and become stronger at high temperatures, below the ordinary atmospheric range. Aluminium and its alloys can be cast, forged, welded, extruded, rolled, etc. The applications of aluminium and its alloys are transportation industry, structural framework, engine parts, trim and decorative features, hardware doors, window frames, tanks, furnishing and fittings, trains, trucks, buses, automobile cars, and aeroplanes use many component parts which are made up of aluminium alloys. Overhead conductors and heat exchange parts. In food industry, aluminium alloys find applications as food preparation equipments such as pans, etc., refrigeration, storage containers, bakery equipment, shipping containers, etc. Mangles and waffle molds are made up of aluminium alloys. In architectural field, these find uses such as window frames, door hardware, roofing, coping seals, railings, fasteners, lighting fixtures, solar shading grills, etc. Cryogenic applications as heavy-duty structures such as dragline booms, traveling cranes, hastes, conveyor supports, bridges, etc. In process industry, parts made up of aluminium and its alloys are used to handle organic chemicals, petrochemicals and drugs. Tanks, drums, pipes, heat exchangers, grating smokestacks, precipitators, centrifuges, valve fitting, etc. are produced from aluminium alloys. The two important aluminium alloys are duralumin and Y-alloy. Duralumin. It contains 3.5 to 4.5% of copper, 0.4 to 0.7% of manganese, 0.4 to 0.7% of magnesium, less than 0.7% of iron or silicon, and the balance is aluminium. The properties are high machinability, high tensile strength after heat treatment, strength as high as steel but has only about one-third of its weight. Excellent casting and forging properties. The applications are aircraft and automobile parts as bars, sheets, tubes and rivets, as light structure and extruded sections. Why alloy? It is also called copper aluminium alloy. The addition of copper to pure aluminium increases its strength and machinability. The composition of this alloy is as follows. Copper 3.5 to 4.5%, manganese 1.2 to 1.7%, nickel 1.8 to 2.3%, silicon, magnesium, iron each 0.6% and the remainder is aluminium. This alloy is heat treated and edge hardened like duralumin. The aging process is carried out at room temperature for about 5 days. The applications are: it is mainly used for cast purposes, but it can also be used for as forged components like duralumin. Since Y alloy has the better strength than the duralumin at high temperature, so that it is much used in aircraft engines for cylinder heads and pistons. Bearing materials. The properties of bearing materials are: it possesses low coefficient of friction, provide hard wear resistant surface with a tough core, have high compressive strength, have high fatigue strength, be able to bear shocks and vibrations. It possesses high thermal conductivity to dissipate heat generated due to friction between the bearing and the rotating shaft. It possesses adequate plasticity under bearing load. Also possesses adequate strength at high temperature. It can be easily fabricated. It possesses anti-seizure characteristics. Be having small pieces of a comparatively hard material embedded in a soft material. Maintain a continuous film of oil between shaft and bearing in order to avoid metal to metal contact. It possesses ability to embed in itself any dirt, etc. present in the lubricating oil. It should be cheap and easily available. Types of bearing materials are copper-based alloys, lead-based alloys, tin-based alloys, cadmium-based alloys. White metals. The alloys in which lead and tin are predominating are designated as white metal bearing alloys. These alloys are used for lining bearings subjected to high speeds like the bearings of aero engines. Lead-based white metal. An alloy containing of 83% of lead, 15% antimony, 1.5% of tin and 0.5% of copper, or 80% of lead and 20% of bismuth is called lead-based white metal. Lead-based alloys are used where a cheap and corrosion-resistant material is required. Tin-based alloys. It contains 88% of tin, 8% of antimony, and 4% of copper. It is also known as Babbitt material. It is a soft material with low coefficient of friction and has little strength. It is the most common bearing material used with steel shell where the bearings are subjected to high pressure and load. Copper-based alloys. The term bronze covers a large number of copper alloys with varying percentage of tin, zinc and lead. Bronze is one of the oldest known bearing material. Bronze is easily worked. It has good corrosion resistance property and reasonably hard. Typical composition of leaded bronze are 80% of copper, 10% of tin and 10% of lead. Copper-based alloys are employed for making bearings required to resist heavier pressures such as in railways. Solid solution. Solid solution means solid state of an alloy containing alloying elements completely dissolved in the base metal. Brass is an example of solid solution of zinc in copper. Chapter number 3, Non-ferrous metals and alloys, is now completed. Thank you students for listening the lecture.